Okay, so this is chapter 4, which was trigonometry. So section 4.1 is radian measure. So a radian is just another form of measurement like degrees. So to go from degrees to radians, you multiply the degree by pi over 180. For example, if you have 40 degrees, then you multiply that by pi over 180. So you get 40 pi over 180. And you can reduce this further by dividing the numerator and the denominator by 20, which equals 2 pi over 9. You can also go from radians to degrees by multiplying the radian by 180 over pi. So for example, if you have pi over 5, then you times 180 over pi. When you do this, both the pi's cancel out, making it just 180 over 5. And when you do 180 divided by 5, it is 36 degrees. Alright, so one of the topics that was covered in section 4.1 is angular velocity. So this is an example of how to use it. So the question is, Bob is riding his bike. The back wheel rotates 12 times in 6 seconds. Determine the angular velocity of the wheel in A, degrees per second, and B, radians per second. So the first thing that you need to do is write down the angular velocity formula. So the formula is angular velocity equals the revolutions times either 360 degrees or 2 pi, depending on whether you're finding it in radians or degrees. And this is all over the time. So to figure it out, you would sub in your values. So the revolutions is 12 and the time is 6 seconds. So you put that into the formula. So for degrees per second, you write angular velocity equals, so the revolutions, which is 12, and then multiplied by 360 since you're finding it in degrees, and all over the time, which is 6. So then you just solve. So 12 times 360 is 4,320 all over 6, which is 720 degrees. So therefore it's 720 degrees per second. In radians you do the same thing. So you write angular velocity equals, and here it's 12 times again, except here you would multiply it by 2 pi since you're finding it in radians, and the time still remains 6 though. And then you solve, so it's 24 pi over 6. So 24 pi over 6 is 4 pi. Therefore, the radians per second is 4 pi. Got it. So the last topic that was covered in this chapter was arc length. So this is an example of how to use it. So the question is, two highways are connected by an on-ramp with an angle of pi over 3 and a radius of 90 meters. Determine an exact expression for the length of the on-ramp. So the diagram is over here. So the black lines are the two highways. The red line is the arc length that we have to figure out, so it's the on-ramp. And pi over 3 is the angle, and its radius is 90 meters. So the first thing you need to do is write down the formula, which is theta equals A over R. Theta is the angle measure in radians, A is the arc length, and R is the radius. So here, theta is pi over 3, and arc length is what we're trying to figure out, so that remains A, and the radius is 90. So what you do is cross multiply these, which becomes, so it makes it 90 pi equals 3A. What you then have to do to isolate the A is divide both sides by 3. When you divide this side by 3, it becomes A, and over here it becomes 30 pi. So therefore, the exact expression for the length of the on-ramp is 30 pi meters.